hear me well?
Yes, I can hear you, Mark.
Okay, great. Thank you. Okay, so Karibuni, welcome to today's session. Hopefully we've had a fruitful week today and a great month. We had a successful meetup last month rather, when we met someone from Sunshine Intelligence Limited, and today we have the head of technology operations, who's going to be taking us through serverless workflow orchestration using step functions. I think this is something I've always wanted to learn and to see how I can be able to use it. I don't think we have any announcements for now. Without further ado, I think I'd introduce Olanyi to come through and just introduce himself and start off. Hopefully you can hear me, you can be able to start.
All right, thank you. Thank you, Mark. Welcome, everybody. As introduced by Mark, my name is Alani, and I head the technology sides of things at Secure Intelligence. A little bit about myself. My work cuts across leading a group of data engineers. Sorry about that. So my work cuts across leading a group of data engineers and cloud engineers. So essentially, I get to decide how my team use some of these resources that we're going to be talking about today. I know that we're about to talk about serverless workflow orchestration, but I think we get to touch more about some of other AWS resources that works alongside step functions, right? So without wasting much of our time, I'm just going to share my screen so that we can walk through it. Yeah, please let me know if you can see my screen, please.
Yes, we can see your screen.
Okay, nice. Thank you. Okay, so today we'll be talking about serverless workflow orchestration using step function. And the outline for today's, I would like to call it conversation, right? The outline of the conversation is going to border around the introduction. The introduction is going to cover what step function is and what exactly we refer to when we talk about workflow orchestration. And we're going to talk about overview of the AWS step functions, building blocks of step functions, designing serverless workflows, of course, using step function, the integration and services. Although we're going to dwell more on that when I get to that section, but by integration and services, I mean, what are the services that can work alongside step functions? How well does step function work with these resources? And we're going to get to talk about the monitoring and debugging of step functions also. And of course, we're going to talk about use cases, and I'll give you some references in case you want to, go back and do more research of your own. Okay. So before we dive right into step functions, it is important because if we go back and look at the heading, we want to talk about serverless workflow orchestration. And it is very important that we understand what serverless is. For some people on the call that are not so technical, or this is their first time hearing this particular term, what exactly do we refer to as serverless architecture? Then we will dive right into a serverless resource that is called step function. So serverless architecture, like I have on my screen here, is a cloud computing model where developers can build and run applications without the need to manage an underlying server. I'm going to try to break that down into a more simpler term. So normally, when you want to build an application, of course, you need to, okay, let me go this route. For people that maybe you're not working with an organization and maybe you're learning one or two things, you're following some tutorials, you'd realize that you actually need your computer in front of you to try out those tutorials, right? You need a server, basically. So a server, a computer, I'm going to use those words interchangeably, right? So you need those things to be able to, deploy a particular solution, to do some testings, to try out some, some logics and stuff like that. And how do you make other people to actually access this particular resource? It means that that particular solution you've posted on your resource, it means that you might need to sacrifice that your particular PC, that your particular server. You might need to keep it somewhere so that people that wants to access it can, constantly make calls to your server, and then they can access the particular logic that you have in there. But of course, like I said, you have to sacrifice it. You just have to keep it there. It has to be constantly on. Otherwise, there'll be downtime. Okay, so the same logic goes to when you go to the cloud and then you provision an EC2 instance. If for some people that would understand what an EC2 instance is when you go to AWS and then you spin up a server and then you deploy a solution on top of it. The server has to constantly run, and then people can access your solution that you have in there. But the other side of it is that you don't necessarily need a server that is constantly running, because when you have a server that is constantly running, you have to pay for it. So either your users are making calls to it or not, you have to pay for the resource running. So this is where, serverless architecture comes in place. So it's more like eliminates your thinking about servers. Now you're thinking more about the application, more about the logic that you want to build into your server. That is the only thing that you focus on. So, you just spin up those resources. They're completely managed for you, right? They are completely managed. You just go in there, put in your application logic, and users can start making calls, or you can start seeing the utilization of that particular logic that you have built. Okay, so essentially it allows you to focus on writing codes without worrying about server management. Like I've said, you don't have to worry about OS upgrade for your server, patching your server, doing all of those things. So that is completely being managed for you. And of course, when we talk about the benefits of this, from my previous points, it is clear that it helps you to reduce operational overhead. So by operational overhead, you don't, after building your application, you don't need to worry about patching, about securing your application. I mean, not securing in that term. You worrying about your application deteriorating, right? Worrying about your application scaling and all, because it automatically scales for you, right? So this is where we talk about scalability and elasticity. Okay, so it scales up and scales down when your application is not in use, or when a lot of users are not currently using your application at this moment. It scales down, and then when you have a lot of users on that particular application, on that particular server, it scales up by itself. Okay, so this brings us to cost savings. Remember, we are still talking about serverless architecture. This brings us to cost savings. So because your application scales down, scales up based on demand to your server, you are able to save some costs in there. And also because you don't have to go do application management, right? Your server management, your server is not constantly running and then costing you costing you money. So this brings us to rapid developments and deployments. Now, remember I said you don't have to worry about the underlying server, right? You don't have to worry about patch management and all of those things. So you are able to focus on writing codes. You are able to focus on developing, on deploying your solution. So because your application scales down, scales up based on the demand, you only pay for what you use. So this serverless architecture has a pay-per-use pricing model. So you don't have, okay, because you've created a particular serverless architecture, because of that creation, you don't get to, constantly pay for that application existing. Only when your application is in use that you pay for it. So if a user, imagine you built an application. In this case, I'm going to use an API. You built an API, and users also are going to be making calls to this particular API. Every time they make a call, you pay, okay? Not every time they make a call and every time your application is running. So only when they make a call to your application, that is when you get to pay for this particular application. Okay, so on this peradventure, you have an application that is not frequently accessed. So on days that they are not being used, you don't get to pay for it. So this is one of the benefits of serverless architecture. And now we've discussed serverless architecture, let's talk about what workflow orchestration. What do we refer to as workflow orchestration? So workflow orchestration involves, coordinating and sequencing multiple tasks or services to achieve a specific outcome. All right, so this is, I'm going to try to break it down. There are some processes. I'm going to bring this to our daily activities. There are some processes that you as a person have to take some particular steps. Once you complete this step, you have to, go to the next step, execute it, then it leads you to another step, then you execute, then it leads you to another step, then you execute, before you can say that, okay, I'm at the last steps, and once I'm done with this, I'm done with the whole of the tasks that I have to do. For you, that is a workflow, because there is a particular part in there that you have to go through. And this part might, the functions in this part might not necessarily depend on one another, right? They might be maybe in parallel, you have to do them in parallel, or you can't do everything at a time. You have to execute one before you move to the next. And then you have to do a series of all of those things. So this is where we refer to as workflow orchestration, right? So in complex application, workflow orchestration becomes crucial for managing dependencies and ensuring efficient execution. So from a previous illustration, it can can blow up, basically, right? It can become something that is so big, because if you have a lot of steps that you have to manage, it can become something that you can lose sight of, something that becomes complex, not easy to handle, and then you have to actually create a workflow, a path in which this is going to be achieved. Okay, so now I'm going to try to combine workflow orchestration and serverless architecture. Okay, I'm going to try to combine the two and then give us the reason why we need to actually have this conversation. The need for us to have this discussion. So imagine you have an application for processing orders, right? You have maybe an e-commerce application, and then your users come in, they try to make orders, and the workflow for you on your application is that you have to get the order, check if the order exists, if the order does not exist, send emails. If the order exists, package the order, start shipping processes, and all of those, right? Imagine you have that. And let's imagine that there is no serverless architecture, and you want to handle this because the request can be so enormous, right? So imagine you want to handle all of this with individual servers. So you spin up an EC2 instance. And by the way, this is not to advocate against EC2 instance, but this is this EC2 instance is what I can use to easily, compare between the serverless architecture and a real server itself. So imagine you have to spin up a lot of EC2 instances to manage each of these stages. You pay for when your servers are running, either users make calls to them or not. And then when they make calls to them, of course, you pay more, and then you pay while it is idle. Now imagine you have about 6 of these, and you have to fit it into a workflow. So every time users are not making API calls, your users are not trying to hold down your application, your server is running and you have to pay for it. So you agree with me that this becomes very, very expensive for your business, and you might not be able to survive it. It becomes very expensive. So if we bring in serverless architecture in here, where you have some specific task that can be executed, you have some specific resources that you have stacked together to achieve the logic that you're trying to achieve, and you don't pay for all of this until calls are being made to your application. I'm sure you agree with me that this will be very, very beneficial for you as a business, right? So let's talk about step functions. So we've talked about serverless architecture, we've discussed workflow orchestration. Now let's talk about step function. So step function is a resource, a fully managed resource from AWS. In case we have some people on the call that don't know what AWS is Amazon Web Services. They are a CSP, they are a cloud service provider. So one of their resources is step functions, and it is fully managed. So it simply means that you just have to go to the resource, create the resource, add your logic, and you can start making use of that particular resource. You don't have to worry about where the the server on which the resource is operating, how you need to patch the resource, all of this. So AWS manages that for you. So it's a fully managed service from AWS, and it makes it easy to coordinate distributed application and microservices using Visual Flows. Hopefully on this call, I get to maybe take us through a very short demo where I can quickly show you the step function console. I hope that I am able to get to that. And essentially, step functions provides a way, a way to orchestrate and manage workflows in a serverless environment. And when I say serverless environment, it means that you can also look for a bunch of serverless resources and stack them together and create your application logic. You can create a pipeline, a workflow, and orchestration. Okay, so what does step function offer? Step function offers, a graphical console for designing workflows. So you can go to the management console, the AWS management console, search for step function, and start designing your graphical workflow. Okay, and this makes it easy to visualize and create complex workflows. So because you can see what you're creating, you are able to expand your imagination and actually create your workflow and see it. So it supports parallel execution. Parallel execution in the sense that you have a workflow in which 2 tasks must, for instance, run at the same time. They don't necessarily depend on one another. They don't necessarily depend on one another. I'm going to show us an example of a parallel execution as we go on. So the step function comes with built-in error handling. Yeah, you can do some form of error handling in step functions using some of the tasks, which I'm going to show you. And step functions seamlessly integrate with other AWS services. This, for me, this is one of the most important thing that I think step function has, the integration with multiple AWS resources. And since AWS have a very large ecosystem of resources that you might eventually need for the bulk of your workload, this integration makes it very useful. Okay, so let's talk about building blocks of step functions. Step functions workflows are composed of various components that work together to define and execute the desired workflow. And the basic building blocks that you need to know about, are the states. I'm going to show us an example in some coming slides. I'm going to show us visuals of these building blocks, how you stack them together to actually create a workflow. So one of the key building blocks, which I would consider would be at the top layer, is the state. And it represents the individual steps, or it can also represent the major action that you want to execute in your workflow. Okay, so inside of your states is where you define your task or decision in which you want to execute in your workflow, and you can connect your states together. You can connect the direction of your states, how the workflow goes. I mean, the flow of the execution and the structure of your general workflow in your states. And of course, inside the states is where you have the task, which are like further building blocks inside your states. And then you have some transitions, right? You have the transitions that define the states based on the outcome of our previous task. Okay, so step function in conjunction with workflow orchestration simply means this. So you start a workflow, you are expecting some certain output, but on that output, you need further processing. So you can take that output and make it an input for another step. Okay, so it's more or less like you have a block, right? The topmost layer starts the execution. You do some preprocessing in there. You apply some logic in there, but the output coming from that first step, you need further processing on it. Maybe you want to send an email, you want to combine multiple data sources together, etc. So the output coming can feed into another task, and you can do preprocessing on that and feed it into something else until you are completely satisfied and you want to end the workflow. Okay, so it basically means that now, since we are going serverless, right? We don't have to worry about the underlying infrastructure. We can now focus on focus on the flow for our orchestration. We can focus on the logic that we want to achieve. We can focus on the business logics, basically, that we want to achieve. Okay. So designing serverless workflows. Okay, so I have a bonus for you here. So step function have different states, right? It has the task, the choice, and parallel states, and we are going to see that in coming slides. Okay, so designing serverless workflows requires that you are equipped with some best practices, and these best practices, if you apply them on your step functions, if you apply them on designing your workflows in step functions, it's going to make you enjoy the usage of step function, is going to make you see the business benefits that you can derive from actually using step functions. Okay, and the first thing you have to do is you need to break down your complex workflow. You need to break it down. Since you're not thinking about servers, you're not managing servers, you can focus on the application. What do I want to achieve? So you break down your workflows into different steps. You break it down into the smallest units, and then you can draw out the workflow by yourself, and then visualize how it's going to work. What do you want at each step of the workflow? So you can do that. You can use task level parallelism to enhance efficiency and optimize performance. And like I mentioned, there are some tasks that can stand alone. They don't depend on the output from other tasks. It can even be a series of tasks on its own. Okay, it can even be a completely different workflow on its own. It can be multiple different workflows. They can run in parallel in step functions. So it's more or less like you're going to have a tree of parallel tasks that once you start the execution of the step function, pulls data from the data source or accepts whatever input, and then starts each parallel workflow. So imagine you have imagine you want to put data from a source, right? Or you want to put multiple data from different sources, and you want your first layer of orchestration to do maybe the API calling, pulling data from database, and start distributing this data into different workflows for different processing. You can design, depending on the source of data that you're getting, you can design individual workflow for each of the data sources, and you can pass them as input into each of the parallel workflows that you have designed. So more or less, it's going to look like you have a tree where the topmost is the input, and then you can separate the output that acts as input to other workflows. So each of these inputs, each of these workflows are in parallel to one another, and different preprocessing can be done on them. So you can leverage choice states to introduce conditional branching within your workflow. So you can check if you have an output coming from a particular step, right? And you are expecting this output. Okay, let me go like this. You are expecting a Boolean value. You know a Boolean value, right? True or false, yes or no, right? You are expecting a Boolean value from the output of one of your steps, and you want to check if this Boolean value is true, then move to the next stage. If it is not, maybe just terminate the workflow orchestration, or maybe send an email, a failure email or whatsoever, right? Or maybe send an email to a user that send a failure email to a user, or a success email, right? So you can use choice states to actually check the output that is coming from your from one of your steps, and then branch out accordingly. Okay, so leveraging this branching is going to make your workflow very, very dynamic and easy to understand. So one of the best practices also is that you need to aim for simplicity. And I think this is similar to the first point. Aim for simplicity. You need to break it down. You need to break down your workflow. So you need to do some form of loose coupling. If there are so many logics and you know that they can sit separately, you need to break down all of those, right? So this is going to give your workflow orchestration some ease, right? And then you'll be able to clearly see the business logic that you're trying to achieve. So this is very important. Is one of the best practices that I would consider when you are designing serverless workflows. Okay. So going further, this is an example of a simple workflow. Okay, so what we have on the screen here is step function in AWS Management Console, right? So the language that you use in designing your step function is actually called ASL, Amazon State Machine Language. You can check it out. So you are able to, use some certain set of JSON formats in order to design your workflow. So each of the steps you are able to design and see. So as you are designing by the left-hand side, you can see the visuals by the right-hand side. So this actually is an example of an order management system, right? Where you have users making order into your application. And what you want to do is maybe you want to check the validity of the order, right? You want to check your inventory. If the item is available, you want to proceed on to the next step. If the item is not available, you just want to send an email to the user that the item is not available, or you just want to return a response to maybe your application that this item you're trying to check is not available. But you want to do this as individual steps. You want to break down the workflow, okay? So this is an example you have in front of you for an order management system. So you can see the branching out of the workflow. These branching out are based on the application logic that you're trying to achieve. But this does not mean that you cannot have a completely linear workflow in step function. You can have a completely linear workflow. Like I said, this is majorly based on what you are trying to achieve. Okay. And I think I have another example here. So this is another example of a weekly digest, right? So imagine you have an application, an e-commerce application, and you want to be able to tell users, you are collecting interaction data, of course, and you want to be able to tell your users that these are your interaction for this particular week, so that when you are doing that, you are able to remind them of what they've been clicking on throughout the week. And if by adventure they've added some of the items to their carts, they will be able to remember that, oh, okay, I actually did this at this point in time. Maybe I should go for it and actually order, right? So you want to send a weekly digest based on the interaction on your application. So this is a very, very simple workflow to achieve something like this. So you pull the data from the database where you are storing the data, the interaction data. You check for availability. Has this user done some reasonable interaction, that you will actually want to display to the user based on your business logic? You generate, then you have different steps. You can see, if you take a look, please let me know if you can still see my screen. So if you take a look at this workflow, you see that at this point, we have we have a box in here, and then we have some parallel execution side by side, right? So this is telling us that this can stand as a state on its own of a new workflow orchestration, where you can have your task running side by side. So you branch out, you can generate statistics, generate summary, depending on what this means for your business, and actually send an email to the user. So I know that you might have had this particular experience, but maybe you are not paying attention to it. But I know that I think Jumia does something like this, where they send you an email, and the email contains your interaction on their particular application, right? Stuff that you've been checking phones, checking clothes, etc. Right? So they send you an email, maybe at the end of the week, and you get this email every time at the end of the week. It has been scheduled to be sent to you. So every time the schedule runs, the workflow starts, it sends you if you have actually done some interaction, it sends you your statistics. There are items that you have actually interacted with, and this can drive you back to the application. Okay, so if you have not done any interaction, of course, you don't get emails. So these are some of the use cases for workflow orchestration, right? And you can achieve this by using step function. It is not limited to this. There are many applications that are doing workflow orchestration that you might not even, you might not be paying attention to. And per adventure, you have some workflow that you want to achieve also. So these are like step function is a tool that you can use in achieving this. Okay. Integration with other services. And when I mean integration with other services, I'm referring to AWS services. Step function integrates very well with AWS Lambda. This is the common examples that you will see. If you do a search on the internet right now about step functions, you are likely to come across the integration with AWS Lambda. And this is because AWS Lambda is also a serverless application, and it integrates perfectly very well with step functions. So you can add your application logic into your Lambda function. So you can have like multiple Lambda functions that execute your application logics, right? And you can build a workflow with these Lambda functions. So you can have, for instance, let's come back here. An instance of what we have here is Lambda functions stacked on top of one another, right? So here, where you have prepared data is a certain Lambda function, okay? It pulls your data, it prepares your data, it checks for more application logic, it checks for availability, then checking for availability is a separate Lambda function. Generating stats, generating summary are separate Lambda functions. And you can imagine these two parallel workflows, right? You can imagine that when you generate stats, you can combine the two outputs into one and send it as an email. Or when you generate stats, you can have more Lambda functions. For instance, you can have more Lambda functions that does more processing after generating stats. Maybe you want to, generate stats, save metadata, do a lot of cool stuffs in there. So you can have more workflows under generate stats. You can have the same thing under generate summary. And those forms a new workflow orchestration for you. So you have workflow orchestration inside a workflow orchestration. So depending on your imagination, your orchestration your workflow orchestration can become so big and so massive. So this can serve as different, application logic sitting inside the Lambda function, and you can stack everything together to achieve a workflow using step function. All right, so step function integrates with S3 also. You can do data storage into S3. You can do retrieval from S3. You can do, triggering. You can build an event-driven application, right? With your with S3 integrating into step function, and then maybe have some lambdas in between that does more application execution. And an example of this can be that you have users upload data into your S3 buckets. So when they upload data into your S3 bucket, you want it to trigger a step function. And then, maybe preprocess, if it is a raw data, preprocess the data, refine it, put it in a new S3 bucket, or, create some metadata and save it in your database, right? So step function also integrates very well with DynamoDB. So one of the things that you can do is you can use DynamoDB to do state management for step function. And I am going to try to paint a scenario for that using our using our order management workflow orchestration. Now you have an application, you want to execute user orders. You have all of these steps, you've created your workflow in this format, but at each point in time, you want your user to be able to be able to see each step in the workflow, right? So you want maybe your front-end application, for instance, once a user makes an action to to order an item, you want them to start doing some processes, like we are validating your order, we are checking order availability. Congrats, order is available. We are checking available shipment has been found. All of those things, you can use DynamoDB to do state management. So each of your steps can feed into a particular DynamoDB table for each session. So you have started your workflow orchestration, right? Let us call that a session. You save the entry in a DynamoDB table, right? And at each step, once validate order is complete, you are able to change the status of that session in DynamoDB table. Status, validate order completed. Then your check inventory step is running. You are able to update that status also, checking inventory. Once checking inventory is complete, you can update that session in DynamoDB table again for checking inventory completed. So you can keep doing that for each of the steps in your workflow orchestration, and you can extend this as an API. Okay, you can extend this as an API to the front end. You can give the front end an API that you can use to always check the status of that particular session. So they can use responses coming from this API to create, for people with front-end experience, you understand what I'm saying? You can create a loading state, right? Or you can even design, some beautiful workflow at the front end for your applications to be able to see where each step of the orchestration is at each point in time, right? They can constantly see maybe your loading state, or they can see a visual of what the orchestration is at the back end, just by persisting your data in DynamoDB table. Okay, so this integration is very, very useful, and it can be used to develop a lot of massive applications and a lot of beautiful applications also. So other services that you can include, that you can integrate into step function are SNS, SQS, AWS Batch, AWS Glue, SageMaker, and a host of them, right? So I have included a link in the reference, which I'm going to show you at the end of this presentation. If you are interested in, taking a look at all of the resources that step function can integrate with, then you can go check the reference. Okay, so monitoring and debugging. When in the state of building a workflow orchestration, it is not free of problems, right? Because you have application logics that you are building, you are experimenting until your workflow is perfect, right? You are doing a lot of trial and error, trying to make sure that you get the desired output that fits into a different state or a different step, and you want to be able to debug your application at this point. Or when your when your workflow orchestration fails, you want to be able to see what failed, which step failed, how it's, what causes the failure. So one of the ways you can do this is integrating CloudWatch logs and metrics into your step function, right? So you can send all of your logs to CloudWatch depending on the scripting language you are using for your processing, your application logic. You can also add logs into your application so that when you go into CloudWatch logs, CloudWatch metrics, you can see all of those logs in there. And of course, you can call out specific steps that you think are likely to fail so that when it fails, you can see it in the logs. Okay. And step function itself provides a visual console for you. So for each of these steps, when it fails, when it's successful, it becomes green. For instance, prepare data. So when you start a workflow and it is successful, prepare data becomes green. But if it fails, it becomes red. So due to these visuals, you are able to know if your workflow is successful or it is not. And then you are able to maybe go into CloudWatch and actually look at what is the cause of this failure. And also at a glance, step function provides execution history and details. So if you visit the step function console on AWS, you will see the list of successful workflows and the list of failed workflows, right? So you are able to maybe inspect the failed workflows and treat them accordingly, or you are able to go evaluate the successful workflow and actually take a look at how your workflows are doing, right? So you can do all of this using the step function console. All right. So this moves us to the use cases, and like we've seen two use cases, doing other processing and fulfillment. We've seen sending weekly digests with step functions. You can also do data processing with your step function. So in simple terms, you can build an ETL pipeline with your step function. So depending on your data processing, you can build ETL, you can build ELT, right? You can build all of these workflows using your step functions. So what you basically need to know and have is your application logic. What are the steps that you want to achieve? What are the workflows that you want to complete? And then you can design this. Okay, so key point to remember: you can build a data processing pipeline with step functions. You can create serverless microservices orchestration with your step function. You can build chatbot and conversational applications. You can build IoT workflows. You can do media processing with your step function. You can create workflows for all of this and actually develop a meaningful application. And one question I usually get is, there is another resource on AWS called AWS Data Pipeline, right? Data pipeline and step functions actually have similar attributes in the way they work. And what I mean by that is they are for workflow orchestrations. But the major difference, in case you are wondering or you have this question in your mind also, the major difference is that the data pipeline is isolated to data workloads only. It's isolated to data workflows only. But you can use step function to develop diverse of workflows. You can design any kind of workflows. Either it has to do with data processing or it does not. You can use step function to design these workflows and actually execute your logic, execute your business logic. This is not the case with data pipelines because it is isolated for data processing workloads only. So these are some references I've added for you. You can check out AWS step functions. These references leads directly to AWS documentation. The documentation is so massive and very easy to understand. So you can go in there and then take a look at how step function works, right? How you can integrate step function into your applications, and some other information that you like to know about step functions. So this references speaks to those. So I don't know if we have any questions or we have Any contribution from the host?
Yes, so just you can send the links on the chat. That'll be okay. And also, if you're able to share the slides, that'll be awesome.
Yeah, I'm happy to share the slides. I'm going to share the slides with you, so you can pick from there.
Yeah. Someone had mentioned there's a part where it had a visual representation of the workflow and a bit of the JSON, I think, script, if I'm not wrong. It was a bit not visible. I don't know if you can kind of blow that up a bit. But I think once you've shared the slides, that will be fine. Are there any questions? If possible, this is the time to ask. You can unmute and ask, and also you can also ask on the chat. As people do that, I'm actually quite curious in terms of like what would be the first ideal project. I was just actually looking through step functions and how I could actually integrate it in what I do. Are there any one ideal beginner project that you'd say someone should start with, especially with step function?
Yeah, thank you for that question, Mark. I think by ideal project depends on which level that you are, right? But I'm gonna say, okay, if you are very, very basic in terms of development and you want to start using step function, I would consider data processing workflows for a start, right? Where you can actually maybe you have some data in the database, you want to bring them in into a workflow, you process them, send emails, you can design some of these workflows to see how step function works, and that is going to fuel your imagination for other use cases on how you can utilize step functions, because the bulk of your use of resources, of AWS resources, any form of resources, is interaction with data. No matter how little, interaction with data. So this is one of the reasons why step function is very useful. So once you can think of a use case, you can think of a workflow, then you can start designing that workflow maybe on paper. You can take it to code and then design an orchestration for it. Maybe you can start from maybe scraping Twitter data, doing some preprocessing, sending emails and stuff like that, or saving it in databases, preparing it. It is a little bit unstructured. You can bring it in, prepare it, make it structured, and then start storing it in a database. So that can also serve as a sample workflow that you can work on to get a feel of how AWS step function works.
Someone actually had asked, sent it on DM, but you had mentioned if you do a demo on how it looks like. I think you said there's a way it goes green or red if it fails. That was really cool. I don't know if you can do that or we're out of time. I do see we are at the top of the hour. Are you able to show that or not possible?
Unfortunately, Mark, I won't be able to show that on this call because we're out of time. But I do encourage you to try it out, and then you can see how it works.
Okay, great. Thank you very much for the wonderful presentation. I think this was quite in-depth and quite eye-opening for myself. I definitely want to try out a few of this and see how I could implement it on my end. I don't know if there are any other questions from the audience, but we can call it a session. Before we do, normally what we do is we'll just take a virtual selfie, if I may call it, before we end, and also kind of network at the end of it all. So you can stop sharing your screen. We can all switch on our videos, take one photo, and then you'll be free to leave if possible. Great. Hello everyone. If you're able to share to what's this called? Is it switch on your camera? That'll be dope. You can take a selfie, then you can call it a Saturday, actually. Great. Hi, Peter. Hi, Veronica.
Hello, Mark.
Great. Hello, everyone. Hello. Oh, let me hide them video participants. Okay. Hopefully your Saturdays are going well. In Kenya right now, there's World Safari Rally. I guess we're the ones who have not gone. We're the ones who stayed on to. Hi, Lorna. How you doing? Hello. Hi. I see Moses is also showing on his camera. We'll do that then. Actually, guys, Lorna has a channel. If you don't mind, Lorna, you can plug it in. I really don't mind. I'm really happy to actually see you here today. You can plug it, then we can call it a day. Moses, we can't see you. I don't know if something's wrong with the camera, but I've taken enough. Okay. Lorna, you don't mind.
There's something wrong with my camera.
No worries, no worries. Lorna, do you want to plug in your channel? I think you should.
Yeah, I can put the name on the chat. That's okay.
Please do, please do. Yeah. So she does have a channel. She's a community builder here, and she does really good work there. Okay, sawa basi. Unless there's anything else to talk about, thank you for coming, guys. This was really awesome. I'd like to thank our speaker today. This was such an in-depth, deep dive in step functions and just serverless workflows. Very informative, and I look forward to actually doing at least a project or two and move from EC to instances and mostly bare metal and go towards something else. Great. I'll give the floor to Adeline. I don't know if you have any announcements or anything else, then you can call it a day. Adeline?
Thank you, Mark. Hope I'm audible enough. And nothing much from my end. Only greetings from Tony. Yes, and to wish you all a good evening.
Oh, yes. I think, Adeline, we had credits to give. I don't know how many people.
I have four. I have 4 credits. So we have the 2 people that joined earlier, and Tony will assist me to pick the 2 other people.
Great. So we'll give, I think, William and someone else, then we'll be giving. So as much as possible, you can come through. If we get credits, we'll be able to give you as you go on. Sasa Basi, do have a great rest of the day. I'll go back to work today, so I'll end the call a bit early today. Bye, guys.
Bye.
Bye.